Hey everyone, so here are the notes for lesson 7. We're going to be talking about repeated zeros. We actually talked about repeated zeros quickly when we first encountered the fundamental theorem of algebra. Well, let's kind of go back over that. So fundamental theorem of algebra, remember that means whatever the degree of the polynomial, remember how we find degree is the highest exponent. So whatever that is, that's the number of solutions. So if we have a degree of 3, that means we would have 3 solutions. If we have a degree of 4, we would have 4 solutions, and so forth. Now, what we also talked about in the fundamental theorem of algebra is that we get exactly in roots when we count the repeated zeros. So that's what we're going to be working with today, those repeated zeros. Okay, let's go ahead, and we may need to write down vocabulary again. So we've talked about this repeated solutions or zeros. So remember, those are solutions that occur more than once. So we're going to be seeing that for today. We've kind of lightly seen it also throughout some of the other lessons. So make sure you pause the video to get this definition down. Okay, let's look at our first example. So it says find all the zeros of f of x equals x to the 5th plus x to the 4th minus 15x cubed minus 5x squared plus 34x plus 24, given that 2 is a 0 and -1 is a repeated 0. Okay, so when we are doing this, as we talked about, we're going to use synthetic division to solve. Now, when we did lesson 6, remember we talked about if they did not give us a 0, we had to use the rational zero theorem. But notice here that they gave us 2 and -1 as the repeated 0. So since they have already given us the solutions or the zeros, we do not have to use the rational zero theorem. What we go straight to is synthetic division. Now, you may be wondering, well, how do I know which one to use first, 2 or -1? So we always want to use the non-repeated 0 first. So always use the non-repeated 0 first. And the reason we have to do this is because since -1 is a repeated 0, we don't know how many times it is repeated. So we'll kind of talk about that when we go through this example. Okay, so as stated, we're going to use synthetic division, just like we did in our lesson 6. So let's go ahead and do that. So we got 2 on the outside. And then remember, we're going to use the coefficients here. So I have 1, and then make sure we go to have an x to the 4th term, which we do, which is another 1. Our next term should be x cubed, which we do have, so -15. Our next term should be an x squared, which we do, which is -5. Then we should have an x term, and then there you go, constant. So remember, if you are missing any terms here, make sure you use 0 as a placeholder. Okay, go ahead. This may be actually a good place right here to pause the video. Go ahead and try the synthetic division. Go ahead and do that. Okay, let's see what you got. So here's what we should have gotten when we did our synthetic division. Since we've done this a lot already, I am not going to explain it. Now, as a reminder, since 2 is a 0, remember we should get 0 as our remainder here. If we do not, we did something incorrect. Okay, we add that, so we get -23. That gives us -46. We add that, get -12. And then we do get -24. When we combine, we get a 0. Yay. Okay, now, normally, especially from lesson 6, from here, we would use these coefficients to write our next polynomial. And so notice here that when we use synthetic division, and this is a reminder, that we always go down 1 degree. So in this case, because we started with x to the 5th, these coefficients would be for a polynomial starting with x to the 4th. Now, here's the thing though. We actually need to get our polynomial to be a quadratic. So need to get a quadratic. Now, the reason we need to get to a quadratic is because there are so many different methods in solving a quadratic. So let's kind of go back over that. Remember, there's factoring, there is square roots method, there's completing the square, and then the quadratic formula. If we use any other polynomial, our really only way would be factoring. So we have to get our polynomial to a quadratic. So how do we get it to a quadratic? Well, this is where the repeated 0 comes into place. So now we need to use our repeated 0 as many times as possible to get to a quadratic. So we have -1 is our repeated 0. Notice we went to an x to the 4th. I need to do synthetic division again until I get to x squared. Okay, so let's go ahead. We're going to do this again. So once again, I'm not going to really probably talk about how to do this since we've done it quite a bit here. And notice we get 0 as a remainder, so we definitely did this correctly because remember, -1 is a solution or 0, so we have to get this. Now, I went from x to the 4th. Now I'm going to do x cubed. Now, notice when I did my synthetic division, I just kind of continued on because remember, these are the coefficients. I can kind of continue on with my synthetic division. Okay, it looks like we need to do synthetic division one more time to get to a quadratic. So that's what we're going to do here. And then I should have -1 on the outside because remember, this is the repeated 0. So you have to have that multiple times to represent that. And once again, we should get 0 as our remainder since -1 is a repeated 0. Now we've gotten x squared. So notice we had to do -1 twice in order to get to our quadratic. So now, just like we did in lesson 6, we're going to take the coefficients and we're going to write this as a quadratic and solve. So let's go ahead and do that. So I have x squared plus x minus 12 equals 0. Now, once again, we can solve. Now, we have a couple ways we could do this. We could see if this is factorable, or we can use the quadratic formula. We can't use square roots because we do have a middle term, and we really don't want to use completing the square because our middle term is odd. So let's see if this is factorable. Well, there are two numbers that multiply to 12 and combine to 1. Those two numbers are 4 and 3. So we're going to have x plus 4, x minus 3. Remember, we're going to set these equal to 0 and solve. So I have x plus 4 and then x minus 3. Now, what we're going to do is list all of the solutions. Now, before I do that, and I should have asked this at the very beginning, I should have asked, well, how many solutions are we going to have? Okay, well, using our fundamental theorem of algebra, our degree here is 5, because that's the highest exponent. That means we should have 5 solutions. And remember, we must count the repeated zeros, and that gives us exactly our in roots, or exactly the number of solutions we should have, okay? So here, writing out our solutions, we get x equals -4, that's one solution. We get x equals 3. And now, so that's 2 solutions, we need 3 more. Now we write the 3 solutions they gave to us. That comes from where we use the synthetic division, or if you want to go back up here where they said 2 and -1 are zeros. So notice 2, we only did that once, so I have x equals 2. But notice with the -1, we did that twice, okay? So now I have to write this twice to make sure I have 5 solutions. So x equals -1, and x equals -1. Okay. So if we count 1, 2, 3, 4, 5, we do get exactly 5 solutions. Okay, make sure you watch the next video. That's just going to be another example, once again, to find all the zeros of a polynomial using synthetic division.